encapsulator technology specialist for hazard control technologies, based out of the Portland, Oregon area. I cover Oregon, Washington, Idaho, and Montana. Um, Great team at HCT. I really enjoy being part of it. Got 34 years of fire and EMS experience. Um, our team is made up of folks all like that. And you can see since 1997, we've been around as a company based out of Fayetteville, Georgia. We're an ISO 9001 company, and we have operations in Brazil, Europe, Nigeria, and Vietnam. So
John,
you can,
I Tammy comment that you have some sounds in maybe in the microphone.
yeah, is it not loud enough?
Yes, you have some very bubbly said.
Very bubbly. Let's see. Let me see if I can move it. Is that any better?
I think so. Yes,
Okay. Let me just kind of move my mic here a little bit. How's that sound?
yes, it's fine.
Good. All right. Terrific. So today we're going to talk about automotive protection and the automotive industry. Everything from road traffic accidents to the production of vehicles, transportation of vehicles, charging of electric vehicles, and the recycling of these vehicles, right? So the cradle to grave protection for this industry. We're going to talk about the risks associated with today's automotive industry, and then how we can mitigate those risks with an NFPA recognized eco-friendly water additive. You know, cars have changed a lot just within the past few years. When you look at the plastics, the composites, combustible metals, we're seeing a lot more in the way of combustible metals going into modern vehicles. Um, Hearing things like pretty soon we could start seeing up to 250 pounds of combustible metals in each vehicle. And that's weight savings, right? We want to reduce the weight of the vehicle, use lightweight components to try to get better fuel economy and better performance. And then we talk about traffic accidents, right? So we have the usual suspects, things like gasoline, diesel, motor oil. But now we're starting to get some unique fuels, things like lithium-ion batteries. Still having mic problems?
Yes,
Uh,
still we listen a little weird the voice, John.
a little weird, huh? How about now? Is that any better? See, I'm trying to move my mic away a little bit.
This a child said meat is garbled.
Garbled. Okay. Garbled. I don't know
Yes,
why.
in this stop there and start to talk in this position.
This position. That work?
I believe
All right. I'll try not to move.
yes.
So anyway,
Say if you are closer maybe of the screen, we can listen better.
okay. So yeah, we talk about these issues with the modern hazards of vehicles, right? We're starting to see hydrogen fuel cells out there. We're starting to see all of our alternative energy solutions. We have to transport these vehicles from wherever they're manufactured all over the world, right? So we talk about roll-on, roll-off ferries and cargo ships, transporting thousands of alternative fuel vehicles, whether they're lithium ion, hydrogen powered, or conventionally powered vehicles, right? So we have those concerns. And then things like parking garages. We're going to talk a little more as we get deeper into the presentation about the hazards and fires in parking garages around the world. They've become very prominent. Those of us in the fire protection world, we're hearing more about them and seeing them more. And we talk about large losses. You know, some of the new buildings, we were talking at a meeting last week, a great new design where they build the building around the parking garage. So the parking garage is inside, basically inside the structure. So again, hazards, right? Propagation of fire that starts in a hybrid or electric vehicle, and then propagating to a residential structure or business. And then the new technology that's rolling out, electric Formula One. So we have Formula E now, and that is something that we're protecting with our encapsulator technology. Very unique challenge, like anything in motorsports, plus lots of composites, plus lots of lightweight combustible metals. So let's talk about numbers and statistics. So, according in the United States, three major classes of fires, categories of fires in 2022. This is from the National Fire Sprinkler Association. Over 500,000 structure fires, uh, which were 35% of all fires reported and 77% of deaths, with a loss of basically $15 billion, right? 15,024 million. Vehicle fires, over 200,000. So again, those fires, those structure and vehicle fires, the majority of deaths and the vast majority of property losses. And we're going to talk about that as well. So yeah, parking garages, right? Um, One of the big issues with parking garages, we worry about a structural collapse. You get a very hot, very intense fire going, especially one involving lithium-ion battery. Can cause major concerns with concrete spalling, damage to rebar, damage to infrastructure in the garage. So Miami, Florida, very recently, February, and then the Luton Airport in England in March, 1,400 vehicles destroyed in an almost brand new parking garage. Car fire in Clearwater, Florida, Swiss garage. We see this going on and on. We see these fires all over the world. I know we have folks here from Australia, South Africa, Canada. This is nothing new. This isn't a nation problem. This is the whole world, and we're all dealing with it together. Fortunately, a lot of the regulatory agencies are starting to recognize the increase in hazards that we're seeing. So FM Global in 21 increased the hazard class of parking structures. NFPA 13 in 2022 recommended raising the hazard class from Group 1 to Group 2. And in 23, NFPA 88A, which is standard for parking structures, requires all parking structures, even those outdoors, are required to have sprinkler systems. And this is good. We're recognizing that there's a hazard. We're recognizing that there's solutions, and the regulatory agencies are bringing us around so we can address those hazards. So this is the worst case. This is something that nobody wants to see. Nobody wants to see a partially collapsed parking garage for a lot of reasons. Loss of life, loss of financial ability. If this was a business, an airport, a shopping mall, a residential area, we've lost the use of this garage now. Reconstruction costs, insurance companies, major payouts, right? So these are all the risks and all the issues we have to deal with, and how we can mitigate them with modern technology using encapsulator agents. So let's start with what is an encapsulator agent. And we'll start with NFPA 18A, which is a standard on water additives for fire control and vapor mitigation. And it defines it defines encapsulator agents, a water additive whose basic building blocks are spherical micelles. And we're going to talk about what a spherical micelle is. These micelles are capable of encapsulating carbon molecules as well as polar and nonpolar hydrocarbon. And the big thing is we're separating fuel from oxygen at the molecular level. Where traditional foams work on a mechanical level with blanketing, we build that thick homogeneous blanket of traditional foam to separate the fuel from the oxygen and prevent vapor release. We're encapsulating at the molecular level. And that molecular level encapsulation brings enormous benefits over traditional legacy agents.
Try to explain, John, because we don't listen the sound.
I'm sorry, Hernan?
Try to explain the video because we don't listen the sound.
Oh, you guys can't hear the sound. Okay. So I'm going to back up. I thought you guys were hearing it because I can hear it on my end. So basically, we're going to look at our basic building block, the spherical micelle. And so, of course, you're looking at a microscopic level here. So there's our encapsulator agent molecule. And we've got a polar head, loves water, wants everything to do with be with water. And then we have our nonpolar tail. And our nonpolar tail hates water, wants to do everything possible to get away from water. So when that's adducted, premixed, or proportioned into the water stream, those polar heads are all going to force themselves outwards. The nonpolar tails are going to hide inside away from that water and form our spherical micelle. Now, millions and millions and millions of these little spherical micelles are going to travel down the water stream until they're discharged from a sprinkler head or a nozzle. Once that water droplet, each water droplet leaves the nozzle, The F500 molecules towards the surface, those micelles break apart. They coat the surface of the water droplet with individual F500 molecules. Those polar heads are hugging that water droplet. They want to be with that water, and those nonpolar tails have turned outward. And inside each water droplet are millions and millions and millions of these tiny encapsulated agent spherical micelles. Now, those micelles are positively charged. And as we remember from high school, right? Positive like charges repel each other. So those spherical micelles in that water droplet, they're bouncing around rapidly inside that droplet, bouncing against the surface of the droplet and then rocketing away. And as we get later on into how we absorb heat better than plain water, that movement of the spherical micelles inside will come into more view. So you'll hear a lot about encapsulator agents. You'll hear a lot of companies talking about they have an encapsulator agent. The gold standard that sets an encapsulator agent apart from other fire suppression agents is the NFPA 18A Section 77 Spherical Micelle Stability Test Protocol. And what that is taking your agent, a liquid fuel, and water and mixing them in a certain ratio along with agitation. So for F500EA, we take 1 part F500, 8 parts of fuel, and 40 parts of water, combine them with agitation, and we then have a stable solution that has the liquid fuel locked up and encapsulated inside the micelles. We wait 2 minutes and we touch a torch to it. We can out of ignition. We then wait 2 hours and touch the torch to it again. It can out of ignition. This proves that we've locked up and maintained encapsulation of those liquid fuels. Now, this is going to be important when we get onto lithium-ion batteries because we're going to talk about the flammable electrolytes inside batteries and how that encapsulation of those liquid flammable electrolytes is one of the major ways we suppress those fires. So we're going to take a look at a video here. So we've got gasoline, poured some gasoline on a flat concrete surface here. And we're going to take some F500. And again, we're getting that 1 to 8 to 40. And you can see the firefighter there is combining it with that agitation. It's really critical we get that agitation to mix that fuel with the F500 solution. So he's going to come and light one side. So with traditional foams, one of the things we talk about is burn back resistance, right? With the blanket burning off. There is no blanket to burn off here. You can actually take that encapsulated fuel, put it in a pan on a hot plate, and actually boil it off without ignition. So now he's going to go and he's going to extinguish that fire. And again, you can see the rapid knockdown as we aggressively cool the fire, encapsulate the hydrocarbons, rendering them non-flammable. Once they've been encapsulated, they're going to stay encapsulated. We're going to bring that torch back. We're going to try to reignite that fuel. That fuel is not going to reignite. So he's working that torch over it. Now, see how he's walking in it? There's no blanket to break. So once that fuel's encapsulated in those micelles, you can kick it, you can scrape it, you can run your feet over it. You're not going to disturb a blanket. What you have is a locked up fuel that cannot burn. So we talk about how versatile F500 is. We talk about the different ways you can use it. And we're going to talk about how being eco-friendly, it ties in very nicely to the initiatives around the world to not only go to green energy solutions, but also as many green solutions as possible, including our firefighting agents, reducing runoff water, right? So that's a big pollution hazard with any type of fire suppression. If we can reduce the amount of water used, we reduce the amount of runoff. It's better for the environment. So here's a test. This was done by the Port Authority of New York and New Jersey. This is a hybrid vehicle. They're going to get this vehicle going. They're going to get battery pack involvement. They're going to come in it with a 60-gallon hand line. So you got the thermal imaging camera. You can see the heat that's being released. We talked about that rapid heat reduction, those spherical micelles, okay, how they're taking that heat, absorbing it, driving it inward into the water droplet. Because we chemically and molecularly change the makeup of water, we absorb tremendously more heat than plain water alone. 6 million kilocalories per gallon to 21 million kilocalories per gallon when we use a solution of F500. You see that rapid knockdown and that rapid cooling. So F500EA, we protect civilians, first responders, business owners, employees, and insurers. It's an all-hazard solution for all classes of industry that are involved in this. For people, by rapidly dropping the temperatures and encapsulating toxic gases and preventing the cohesion of free radicals, we improve visibility. We create a safer evacuation corridor. We get a faster knockdown on the fire, and we reduce the concentration of toxins. You see this gentleman carrying his e-bike on board a subway train. This is a very common problem now we're seeing with e-mobility devices aboard mass transit. Um, because of our ability to prevent the cohesion of free radicals and forming toxins, to reduce the heat, eliminate those toxic smoke and gases, we create a much better environment for firefighters, better visibility. You can stand up and navigate. You don't have to crawl around. F500 is also multi-class. So we work well on Class A fires, especially tire fires. Class B. And when we talk about flammable liquids, we also talk about three-dimensional flammable liquid and gases. Class D, metal fires, very effective, as well as lithium-ion batteries in energized environments such as transformers. For business owners, again, how long can you afford to have your business down? How long can you afford to have lose the use of your business, your warehouse? Can you afford to lose charging stations for equipment? So we want to limit that fire damage, prevent loss. And again, at the same time, we want to be environmentally responsible. F500 encapsulating agents are fluorine-free, non-corrosive, and biodegradable in the environment. F500EA is actually food safe for mammals. Very, very nice agent when we talk about being environmentally responsible. And again, its use reduces the concentration of toxins. We keep our employees safe in facilities protected by F500. We give them better visibility, reduce heat, give them a better chance to evacuate. And again, those jobs, right? When a business is down, people are out of work. Production has to stop. We don't want to see that. And then for the folks that insure these facilities, because we have a proven track record of reducing damage, limiting fire damage, limiting loss, reducing the amount of water, reducing water damage claims, preserving structural integrity. Again, we provide a great solution for insurance companies to ensure that the places they're insuring are safe. So let's talk about our newest thing. AP Plus over in Spain recently rolled out a new parking garage protection system. We look at a lot of places around the world. We're seeing this explosion in charging stations. We're seeing more and more EVs. We're seeing this drive towards net zero. We're starting to see these large scale vehicle charging stations popping up. So DECRA, they're a fire and building code consulting service. They're one of the world's largest testing, inspection, and certification organizations. They inspect 28 million vehicles a year, more than any other organization. So they looked at lithium-ion battery fires and tire fires. And I know for a lot of people in the automotive industry, tire fires are one of the worst threats we can deal with, not only because of the volume of fire, but the production of massive clouds of black toxic smoke. And then because so much water has traditionally been used, serious runoff and environmental problems. In October of 2011, DECRA released a letter saying that they find F500EA more effective than any other extinguishing agent for fighting these types of fires. And that ties right into our diamond doser water-driven proportioner. This is a system requires no electrical power. It's a flow-based proportioner. So as the flow increases, the amount of agent increasing is discharged with it. The great thing about the diamond doser, it can be either installed in new installations or slotted into existing sprinkler systems. So You can use your existing sprinkler infrastructure, sprinkler heads, everything, and you can see how this slots right into the sprinkler riser piping. Really basic view of how it works. Very simple system. Water is coming from the left. That's our fire feed water. Turns a paddle wheel. That paddle wheel drives a piston pump, and that piston pump injects the F500 downstream. And again, because it's flow based, it's metering the appropriate amount of agent to obtain the percentage that you're looking for. You can go as low as 0.5% to 1 to 3% based on your hazard. Our smallest unit, 48 gallons a minute on the maximum. Our largest, 2,600 gallons per minute. And they can be placed in parallel. So in this case, if you needed 5,200 gallons a minute, you could place two of the largest units alongside of each other and get that high output. And again, you can use either bladder tanks, which you see up on the right, or with the diamond doser, that's an atmospheric tote. So you can see the tote's on a containment structure. It's above the diamond doser, which is on the floor there, and feeds via atmosphere. One of the great things about testing, when you do your annual testing on these devices, you can get the option to recirculate the agent back into the tank. So you can test with plain water and recirculate and not have any agent loss. So that's great, especially for applications that are deep indoors or deep in a facility where you don't want to waste anything. HCT, we have our own in-house engineering staff. So when your fire protection engineers are ready to start a project, they reach out to our engineering staff and we help them every step of the way, all the way through commissioning services. So here's a quick video on the Diamond Doser family and modern parking garages. So AP Plus, in July 9th, they got their complete system for electric vehicle charging protection parking garage certified. And this is the live fire testing that was done to achieve that certification. So this is a tunnel lab. You see you have a vehicle in the center, and there's a fully involved, fully charged lithium-ion battery pack underneath it. Now, there are 6 sprinkler heads overhead. Those activate based on a gas and flame detection system. Now, this test is important because what had to happen was once this system operated, it had to contain the fire to the vehicle of origin. It could not allow damage to the vehicle next to it. And as you can see, it had to maintain an escape corridor. That's that space to the left. That could not have any concentration of toxic gases, and it could not get above 60 degrees centigrade. They were able to pass that test. And that system now is installed and protecting a parking garage in Spain. So those 6 nozzles discharged about 32 gallons a minute of a 2% solution of F500. And it's going to show you right here that while they had almost 4,000 gallons of water, the fire was contained using only 297 gallons in 4.5 minutes. Now, that system applied, it's going to get up here to how many gallons of agent it applied. So mixed with that water, show you right here, 9 gallons of concentrate to contain the fire. And again, when we talk about that egress corridor alongside the car, that's your access and ingress corridor for your firefighters. So not only are we making it safer for the folks that are trying to exit, we're making it safer for the firefighters that are coming to extinguish the fire. And you can see the setup, the behind the scenes here with the diamond doser and the tote. And even though that was a 50 kilowatt hour battery, the only damage to the vehicle alongside was some blistered paint and a melted mirror that occurred before the system discharged. After that, there was no additional damage to the exposure vehicle. So now we have that system in Spain, and we're going to show you a system that went in electric buses. So this is in Madrid. Turn my sound down again. So we're in Madrid, Spain here. This is a large-scale EV bus charging area. They have photovoltaic panels on the roof. Those supply battery energy storage systems for when the weather is poor, it's dark. It's got an open head deluge system that is activated like what you just saw in the previous video. That's in place right now, protecting these buses. Again, this is a worldwide hazard that we have the solution for. So let's see what it looks like all up. This is the Elitex electric car protection. We're going to see what the system looks like inside that parking garage. So you see you have your electric vehicle charging stations. You see you have your sprinkler piping overhead and your smoke and toxic gas sensors. Those gas sensors are important, right? Because what's the first sign normally of a thermal runaway event in a car battery is the liberation of toxic gases. Those gases are going to go up. It's a double redundant system, so it's going to trip that system. Once it operates, you can see you got a diamond doser and a concentrate tank inside that small room. It's going to activate, and it's going to activate the heads directly over the fire vehicle, and it's going to activate the heads over the exposure vehicles on each side. So it activates, it begins to alarm, it sends an automatic fire alarm to the fire department, and that system is going to open those heads. The diamond doser is going to proportion the F500 into the stream. And again, you can see how simple a setup this is. It's going to discharge out of those heads and it's going to start to contain the fire. And it's going to allow time and space and clear air for the people in the garage to evacuate, and then the responding firefighters to access the vehicle and complete final extinguishment. So who's using F500? Well, we have folks like GM, we have Tesla and the Panasonic battery factory and the Gigafactory in Sparks, Nevada, Formula E, Jaguar, Goodyear is using it to protect their tire storage, BMW and Porsche. So we have a lot of different companies that are using this technology, that have been testing this technology again for over 15 years. We've had companies looking at this technology and putting it in place with great success. Wow, we got through that in about 35 minutes there. That was quick. So here, we're going to open it up to questions now. I know we went through it kind of quick. Wanted to give enough time here at the end because I know a lot of you are going to have questions about what we talked about, and we can kind of go back and look at some of those different slides if we need to. So, Hernan, let's open it up to questions.
Yes, in this moment, thank you, John. We try to deal this sound problem, but if you don't understand something, we will send to all of you this PowerPoint, and the video will be in the YouTube channel. And we have 3 questions. See? Roberto Guerra from Peru, John, asks if there another product mentioned in NFPA standard able to pass this test.
So, is there a standard for F500?
Yes, some similar like the F800. I know.
Yes.
Now, let me answer this.
Yep.
We know that different product they start to promote in the website that in the NFPA 18A in the Annex 0.43 talk about lithium battery that if you pass the NFPA 18A section 77 and you pass different third-party tests, you can use this product on lithium batteries. Some products say that they pass the NFPA 18A section 77. You have to be sure that this product pass. We saw that there are some products that mention that they pass. We found a company in China that they put the name A500 foam, and they started to sell fire extinguisher, saying that they are encapsulated agent. You have to be careful with this. If don't pass the NFPA 18A section 77, be careful using these agents that don't pass this test on lithium battery, because this this agent, the encapsulator agent, the encapsulator technology can stop the propagation of the thermal runaway. Other products like foam, they don't stop the thermal runaway. They don't stop the propagation of the thermal runaway. But yeah, there are different products in the market that they say that they work like an encapsulator agent. We
Okay.
have,
Can I add something in here?
yeah, please, Mike.
There are certain products out there that say they're a foaming agent, but the real question is, do those foaming agents pass UL 162, which is a foam test protocol? So if you pass, then you are UL listed as a foam. So the NFPA 18A section 77, as John has up on the screen, is an encapsulator agent test protocol. This test here is to an encapsulator agent, just like UL 162 is to foam. This is called a spherical micelle stability test because the spherical micelle is the basic building block of an encapsulator agent. And this test shows, does an agent actually have spherical micelles? Number two, are those micelles capable of encapsulating fuel? Number three, are they stable in the presence of high heat, hence a 1-minute ignition test? And are those micelles stable over a long period of time, hence a 2-hour ignition test? I'm aware of 5 different companies that claim they're an encapsulator agent. We don't have the resource to test every product that comes down the pike to decide, are they actually an encapsulator agent or not? I think that's up to the end users to require a UL witness test that they actually pass 7.7. That is a test that we have done. We completed that testing in February, and we have a third-party independent UL witnessed document that shows F500 is an encapsulator agent. So as you point out, we know there's other companies who represent their product by the name of F500, but when you look at the spec sheet, you clearly see that it is a foam based on bubble technology and not an encapsulator agent. So I don't know if anyone else actually meets that test. There's people that claim it, but to be sure, the end user should require a third party UL certification or at least some witness testing documentation that the product actually is an encapsulator agent.
Mike, thank you for. I have 6 other questions. Maybe you can interview here. Because Jack asks, how much pressure loss from inlet to outlet of doser?
Inlet to outlet of what?
Doser, the diamond doser.
Yeah, it's approximately the same. They vary from doser to doser. So we have smaller dosers at 180 liter per minute all the way up to 10,000 liter per minute. It would vary by doser, but it's usually maybe 10 to 20 psi or pressure loss through the dosers on average. And it also depends on whether you're trying to flow at the maximum. For example, if you had a diamond doser 8,000 liter per minute and that doser can flow up to 8,000 liters per minute and you're pushing 7,500 liters per minute through it, you're going to have a higher pressure loss than if you had, say, a 10,000, a diamond doser 10,000, and we're pushing 7,500 through it. So again, we have data sheets on each one that we would provide, and we work with your team to help with the proper selection of equipment so that you get the sprinkler densities you want coming out of the nozzles.
Yeah, we have this chat. We have different questions in the chat and in the question and answer. And rule of thumb percentage: 1% for class A fire and 3% for liquid, pressure, three-dimensional fire, lithium battery, metal fire. The other question, John, that we have here, and Mike too, I'm most interested in retrofitting existing wet-dry sprinkler system for lithium protection. It's not a question, it's a Brent said, are you seeing the same runoff with the
Yeah, the LPO4 batteries.
lithium batteries that are used in the marine industry?
So
Yeah,
what's
the
great?
answer to that is no, or not. When you put lithium ion batteries out with plain water, you're using copious amounts of water. Now, I'm not sure what copious amounts of water mean, because all of my engineering years, that was never a term that was put to us. And I've seen a Tesla car that was dumped into the bay and it continued to burn underneath the water. So from that, I might consider maybe the Atlantic Ocean is copious amounts of water. So that's the first thing I think everybody needs to think about is if we need copious amounts of water, we're going to have copious amounts of runoff. When you put water on these batteries, you end up with hydrofluoric acid type runoff. So that's a hazardous material. Now you're creating a huge expense for the owner of the building for disposing of that runoff water, or maybe for the fire department. With the F500 encapsulator agent, we are using very reasonable amounts of water because we're using the cooling characteristics of the spherical micelle. We're encapsulating any exposed electrolyte, rendering it non-flammable, non-ignitable. And, we have a study that was done by SGS, which is the largest phys chem testing laboratory in the world, that shows the runoff of plain water, the runoff of just an F500 solution. There's nothing in there that wouldn't allow you to put it through a industrial wastewater treatment plant. The agent's 100% biodegradable. They evaluated the runoff of lithium ion battery extinguished with the F500 solution, and there were some presence of heavy metals, so they said it would be fairly easy to precipitate out the heavy metals, and then the rest of it could be run through an industrial wastewater treatment plant. So a much easier to handle the runoff of the F500 than it is plain water, because we're not creating the hydrofluoric acid because of the molecules on the surface of the droplets, or what's coming in contact with the battery itself and not the H2O molecules.
Okay, thank you. I believe, John.
By the way, just by comparison, in the NFPA funded research project, they were using a lithium ion battery with 16 kilovolt, and on average used 1,700 gallons of water to extinguish that, and they still experienced thermal runaway up to 72 hours later. We did some independent scientific third-party testing with Fraunhofer University, which is a highly regarded engineering university in Germany. It was a 20.4 kilowatt battery. We utilized 2 sprinkler heads, and the total solution to extinguish a battery that was 20% higher than the NFPA funded battery from the funded research project was a total of 4 gallons of F500 solution. So those are the magnitudes we're talking about: 1,700 gallons versus 4 gallons. Even if they ran the sprinkler a little longer, you're talking 10 gallons. There's not a comparison, especially when you're considering disposal cost.
Yes. Okay, thank you, Mike. I believe that you answered different questions here in the. I want to finish in the question and answer and then move to the chat, John, with the other question.
Okay.
Here, Jean said, in the bus example, you mentioned a battery storage system providing power during low solar times. Are those storage systems protected as well? I believe, Mike, if you know something about Spain.
Sorry, I missed the question.
He said, we put the bus example of Spain and comment that the storage system can be protected with A500. The question is if the storage system can be protected with the.
Yeah, are you talking about the battery energy storage system?
Yes.
Yes, yeah. So whether it's, lithium ion battery on a bus or a forklift or whether it's battery energy storage systems, while the batteries do have slightly different chemistries, our agent works in the same way. One, encapsulating electrolyte to make sure it's non-flammable, non-ignitable. We use the spherical micelles to change the heat reduction mechanism of the droplet to rapidly reduce the heat below the auto ignition temperatures of the electrolyte. And so it's the same. And we do have, if anyone has a battery energy storage system application, we actually have an installation in Kansas that we would be glad to share with and discuss and show the concept on how we approach that project to provide fire protection for the battery energy storage system.
Okay. Other question in the chat said, does the weather temperature have any effect on the product?
Yeah, so it needs to be protected from freezing. What's interesting about the product, unlike some other water additives, if it does freeze, once it thaws, there's no change to the agent. So while you should protect concentrate from freezing, were it to accidentally freeze, it won't hurt it once it thaws out. When it's used pre-mixed in either extinguishers or our quick attack mobile units, they can be freeze protected with the addition of virgin propylene glycol. We like food grade propylene glycol. You want to avoid recycled propylene glycol because you don't know what other contaminants it may have picked up. But using propylene glycol, we can freeze protect extinguishers down to minus 31 degrees Fahrenheit by adjusting the amount of propylene glycol with water. And that propylene glycol has no effect on the extinguishing ability of the solution.
Okay, let me move forward with other question. I believe this question can be for Mike. NFPA 10 indicates that only additives identified on the original nameplate shall be permitted to be added to water type extinguisher. Are there extinguisher manufacturers that have A500EA identified on the nameplate in the US?
Yeah, Hazard Control Technologies. We sell an F500 fire extinguisher. It's not currently UL listed. We are engaging with UL, getting our proposals to move forward to get UL listed fire extinguisher. Unfortunately, neither UL or FM Global have any current listing criteria for a lithium ion battery. So we would move forward to just get like an A listing, 3A, 4A, in order to, just have a listing that people want to feel warm and fuzzy about and utilize the rest of our intellectual property to sell, the capabilities of the encapsulator agent for lithium ion battery. But we currently do sell a 2.5 gallon, 9.7 liter fire extinguisher with F500 3% solution and have our labels on it.
Yeah, and so remember, under NFPA 10, you can include those extinguishers under the supplemental extinguisher classification NFPA 10. So while the water extinguisher may, be a UL rated water extinguisher, and the F500 agent is UL listed, right? So when you combine things together, that actual whole has to be UL listed. So that's the process we're working on. But for right now, if you have a lithium ion hazard and you want to hang one of our extinguishers next to that hazard to protect it, that's totally allowed under that supplemental extinguisher category of NFPA 10.
Okay, thank you, John. Dice, the same person have for water type for extinguisher, how often is the water A500 EA solution required to be changed?
So when premixed, we say a solution, premixed solution of F500 should be changed every 5 years. And that works really well because your water extinguishers need to be hydro tested every 5 years. So they have to be dumped out anyway. You have the hydro done. And so you do the hydro when you recharge them, fresh concentrate and water.
Okay, and the last question of this chat, I want to move to the other chat. He said, do you have experience using A500 EA in fixed system protecting aircraft hangars?
So we are working with a couple of different folks. In fact, right now I'm working with a contractor on an F500 hose reel system for a rooftop helipad at a hospital. So under NFPA 409, standard on aircraft hangars, and NFPA 418, standard on helipads and vertistops, they now allow a engineered solution approved by the authority having jurisdiction in place of the they've put in there before. So yeah, you can use this in aircraft hangar protection under that new NFPA 409 change.
Yeah, in fact, there was a one-page flyer that was issued by the NFPA research, who did the research on it and showed that there was testing actually done with the F500 encapsulator agent, making it a very viable alternative to foam on those. And in the last revision of 409, which is currently in revision cycle, we submitted some public comments, and they just had their first technical committee meeting last month, and I haven't seen the first draft, so I don't know the outcome of them. We currently have over 300 fixed systems in place, protecting under turbine lube oil, transformer fire protection. The specialty that we kind of focus on is three-dimensional flowing fuel fires, three-dimensional spray type fires, and so if you're talking about a hangar type fire, it's going to be a flowing fuel fire across the bottom of the hangar floor. So that would be a good application for the F500.
The same person, Mike, put here in the chat, will you please confirm that in the USA there is no requirement for a sprinkler or nozzles to be listed approved for use with water A500 EA solution?
Yeah, I certainly can address that. I know that here in the US, everybody has a great concern about, when they're taking and trying to apply their foam knowledge to an encapsulator agent. And when you look at foam, foam is a bubble structure. We're trying to build a blanket, and the bubbles and the integrity of the bubbles are quite closely tied to the equipment that the foam concentrate or solution goes through. So, I'm very familiar with the foam listings, and under those listings, there's 8 or 9 different criteria, including the bladder tank, the concentrate, the ratio controller, the specific nozzle, the application density, the pressure at the head, the flow going through the ratio controller, the type of fire you're putting out, and K factors. So there's a whole bunch of things But we have to understand that the bubble is mechanically made. So when you alter any of those things, you alter the integrity of the bubble structure. With an encapsulator agent, it's based on spherical micelle. And once the agent goes into the water, you instantaneously and automatically create the spherical micelle. You cannot not create the spherical micelle. That's what the agent does. So the two things that are important in any type of application with an encapsulator agent is one, making sure we have the proper proportioning rate, 1% on class A, 3% on class B, and lithium ion battery and class D materials. And two, making sure that we have the proper application density over the entire hazard. So it's much simpler. It doesn't really rely on, oh, you have to have this special aerated nozzle, or you have to have, a different type, a very specific nozzle, because you're not creating bubbles. You're only making sure you have the proper density over the hazard. So.
Okay. Thank you, Mike. We have the last minutes. John, we have, I believe that this is for you, and you can explain better the question of Eric. What is A500's ability to hold its integrity for any period of time when just water is continually added to the application area? For example, your system activates and discharges, but due to step notification time, response time by the fire department, and their operational and tactical time, all before the system is shut down, or taking into consideration fire department hardline operations? Are the systems designed to take this into consideration in the design for the amount of concentrate needed?
Yeah, so I can tell that that question is very much based on a strong foam knowledge base. So here's the difference. If you put down a foam blanket and you're separating the fuel from the oxygen, and you happen to run out of concentrate, and now you're putting just plain water on, that plain water starts to break down the bubble structure, and you start to break down your blanket and you get reignition. This is a totally different technology. So here, what we're doing is we're encapsulating the fuel molecule inside the spherical micelle. So think of the micelle like a molecular safe, a chemical cocoon, a molecular chemical cocoon. Once you put that fuel molecule inside the spherical micelle, it's not coming out. So if you add more and more plain water and you start to dilute down, it doesn't matter, because the fuel is inside the micelle. Now you just have more room for the micelles to spread out. It's not like oh, I've added more water, so I'm breaking the micelles down. No, once you've encapsulated, the fuel's in the micelle, it's not coming out, and you're just giving more room for them to spread out. So it's a totally different mindset, because we're so used to 75, 100 years of foam, that things that are certainly considerations for foam are not really a consideration for an encapsulator technology concept. I hope that answers the question, if I understood it correctly.
I think so. I don't know if Eric can put, I don't know. Yes, answer very well. I believe that in your answer, Mike, you answer other question. I don't know, James Comier puts, can you repeat what the liquid fuel component is? I believe this is for you, John.
Yeah, so it's pretty easy. So what we do is, when we do this lockup test, we'll take 16 ounces of the F500EA concentrate, 1 gallon of our flammable liquid, say gasoline, and then 5 gallons of water. So, as a street firefighter, math sometimes be hard at 3 in the morning. Basically, with a 3% solution, it's 1 to 5. So if I have 1 gallon of gasoline on the ground from a car accident, I need to put 5 gallons of a 3% solution of F500 on it to achieve total encapsulation when combined with agitation. So that 1 to 5 is a really good street ratio. You got 100 gallons of gasoline down. You're going to need 500 gallons of 3% solution of F500 combined with agitation to fully encapsulate it. And in those cases, your combustible gas detector is your best friend, because as you work to encapsulate that fuel, you're going to work that combustible gas detector over the surface. And once you detect zero LEL, the surface of the spill, you know you've achieved total encapsulation. So I hope that answers that question.
Yeah, if we look, John, if we look at the ratio there of 1 part of F500 to 40 parts water, that's still up on the screen. 1 divided by 40 is 2.5%. And we actually dial up 3% on the fire ground. And when we're doing a fuel neutralization, say on a spill on a highway. So we have a factor of safety of 1.2 there. And the ratio you mentioned of fuel to water, 8 parts to 40 parts reduces to 1 to 5. It's a very simple calculation. You go, oh, I got 20 gallons of fuel spilled. You're just given an estimate. So you go, okay, 20 times 5 is 100 gallons. Oh, I'm using a 95 GPM nozzle, so it's going to take me about a minute to spray in here and encapsulate all that fuel. And you're absolutely correct. Take your LEL meter, and once you're at 0, there's no need to add any more. If you do add more, you're just adding extra micelles that aren't encapsulating anything. Putting more water down to spread micelles out is not going to be an issue.
I believe that we have other, because we passed 5 minutes of our time. We have 2 different questions, and I believe it's the same. One question in the chat said, can you explain, please, how the micelle reacts after interacting with or reacting with the fire, hydrocarbons? Sorry, what part of the polar head grabs the heats, hydrocarbons, etc.? Thanks. And the other question in the question and answer chat said, regarding missiles, when eject proportions into a fire sprinkler, for example, of 3%, sorry, do the F500 missile spread on or grow into the entire volume of water?
Yeah, so it's soluble in water, right? So when you pour the concentrate or eject the concentrate or proportion the concentrate into the water, it's going to rapidly get into that water and spread out. And so, yes, as those drops discharge the nozzle out of the fire stream, you should have that solution at whatever percentage you're ejecting or proportioning coming out. For the first question, Hernan, you want to give me that first one again?
Sorry, I have an attack of cough.
Yeah.
So
What was
can
the
you
first part of
explain? Yes, can you explain, please, how the missile reacts after interacting with the fire, hydrocarbons? What part of the polar head grabs the heats, hydrocarbons, etc.?
Okay, great. So that's a great question. So on the surface of that droplet, you've got that skin of F500. And so this is where thermal conveyance comes in, right? That heat is going to get driven inward into the droplet. Those micelles that are bouncing around in there are going to grab that heat, draw it away, take it inside the droplet, and then slowly dissipate it. So that's why a normal droplet of water boils at 212 degrees, where a droplet that's treated with F500 boils at 248 degrees. Why does it do that? Because we've chemically and molecularly changed the performance of the water. Just like when we encapsulate a hydrocarbon and those the micelle grabs that hydrocarbon, draws it inward to the center, and locks it up in a chemical cocoon, and prevents it from coming back out again. So once we've cooled that spill fire, say, and those hydrocarbons come in contact with that micelle, it's going to draw those molecules, the hydrocarbons, in and catch them in that chemical cocoon.
Okay, thank you. And is there a shelf life expiration for A500?
Shelf life, yes, 15 years.
Thank you. And the last question is, application on EV burn test is overheat. Is it as effective as application of A500 and water from under the vehicle, under the car?
Yes. So we have the ability to install basically deck-mounted nozzles that can spray up underneath. So you have to understand, in those parking garage tests, the idea was to contain the fire and smoke and hazardous gases, right? So when the fire department shows up and we go to complete final extinguishment, yeah, we're going to move around the vehicle. We're going to apply from underneath. We're going to apply into the car. One of the great things that those batteries do for us when they do go into uncontained thermal runaway, they tend to burn holes nice and clean through the battery pack. And that F500 tends to work its way down inside and encapsulate that flammable electrolyte and cool the other cells that aren't involved yet. So yeah, what you're trying to achieve, whether it's control or extinguishment, is going to be the type of system you have to apply the agent, if that makes sense.
Okay.
So in that AP plus test, though, even though they were sprinkler heads coming from above and the battery was underneath, we'll first stop the propagation of the fire to the adjacent car, kept the temperature in the evacuation corridor below the required temperature. I think the pass fail was 60 degrees C, and we kept the temperature there below 30 degrees C. And the ceiling temperature of the pass fail was 70 degrees C, and we kept it below 40 degrees C. And after 10 minutes of sprinkler operation, the temperature at the ceiling was the same as it was before the fire started. And ultimately, the sprinkler system did extinguish the car, even though that wasn't one of the pass-fail acceptance criteria. It was just to contain the battery. Did extinguish it in approximately 40 minutes. Now, why is that? It's because the batteries are burning so hot, they burned through the bottom of the car and burned up the interior, that then allowed the F500 to sprinkle the interior and sprinkle and put the battery out. So, but again, that wasn't one of the pass-fail criteria. It was to keep things cool, to protect the parking structure from collapse like we saw in London.
Hey, thank you, Mike. Thank you, John. We are 11 minutes after our time. And I want to say thank you to everybody for your question. Thank you, John, and thank you, Mike, to explain all the different the answer. And please, John, if you want to say goodbye to all our people around the world.
Hi, everyone around the world. Thanks for attending, and reach out anytime if you have questions. Our team worldwide is ready to work with you and help you on whatever you need.
Thank you, everybody, and we will in touch for the next webinar, and you will receive an email in the next days with this presentation and the links to enter in the video of YouTube. Have a good day, good afternoon, good night, and have a blessed day. Bye, John. Thank you so much for your time.
You bet.
Bye-bye.